Okay, so for part two, we're going to have a look at some calculations that we might come across. Before we start, we talked about the number in the previous example was 6 by 10 to the 23. Now 6 by 10 to the 23, in case you come across it, is called Avogadro's number. And Avogadro was an Italian chemist who came up with this idea. So Avogadro's number. You'll also see when you're going across the internet, you may see this written as 6.02 multiplied by 10 to the 23. And this is also Avogadro's number. But for leaving cert, we just need to worry about 6 by 10 to the 23. 6.02 is a little bit more accurate, but you don't need to use this. And in fact, this particular number actually continues on for several decimal places. So that's all we're interested in. So that's Avogadro's number. So what we're going to do is have a look at a couple of calculations. We'll look at the first question. What is the relative molecular mass of water? And basically this particular line here, relative molecular mass, is asking you to work out the mass of H2O. So for H2O, again, we go to the periodic table. You should know these, but H2O, MR is the relative molecular mass. So this is the symbol that indicates the mass of one molecule of water. So it's 2 times 1. And it's 2 times 1 because if we go to our periodic table, we can see here that hydrogen at the very top has got a mass number of 1. So it's 2 times 1 because we've got 2 hydrogens. We're going to add to that the oxygen. So again, if we go to the mole or the periodic table of the elements and we look at oxygen, we can see oxygen here has got a mass of 15.999, which is 16. So we're going to add 16. So that means the molecular mass is 18. And that's it. There's nothing else to that. That's the molecular mass of water is 18. Let's go on to the next one. So the next question, what is the mass of 3 moles of aluminium atoms? So we need to turn 3 moles of aluminium atoms into a certain amount of grams. Well, there's several ways you can do this. The way we're going to do it at the moment is we're going to find out what 1 mole is. It's asking for 3 moles. Let's go work out what 1 mole is. All you have to do to find out 1 mole of anything is go to the periodic table and find it on the periodic table. We're looking at aluminium. So if we go to aluminium, let's find aluminium, which is here. So aluminium is number 13. And it is 26.98, which rounds to 27. So we're going to round up, obviously, in this case. So the mass is 27, and it's the mass that we're interested in. So 1 mole of aluminium is 27 grams. And we learned that in the first video. If you're unsure of that, go back and look at the first video again and make sure you understand it. If 1 mole of aluminium is 27 grams, well, then it's easy to figure out 3 moles of aluminium. All you've got to do is multiply 1 mole by 3 to get 3 moles, but you also have to multiply this by 3 to keep the equation balanced. So that's going to give us a total of 81 grams. So 3 moles of aluminium is 81 grams, and that's your final answer. If we move on to the next one, the next one is what is the mass of 1 mole of sulfate ions? So again, this one can catch a couple of students out. Again, it's looking for the mass of 1 mole of sulfate ions. So 1 mole of sulfate ions, and it tells you it's SO4 di negative. Now, clearly, SO4, and never mind SO4 di negative, is not on the periodic table. So this is a molecule that we're going to have to work out. So working out this molecule, we go to our periodic table. We need S and we need O4. So going back to our periodic table, let's have a look for S. S is here, there's sulfur, and that is 32.066, so this is going to be 32. So sulfur is 32, and we also need oxygen. Oxygen is 15.99, which is 16. So oxygen 16, sulfur is 32. So sulfur is 32 plus we've got 4 oxygens. Those 4 refer to the oxygens, not the sulfur. So it's 4 times 16. And that's it. This 2 negative is irrelevant in this question. So SO4 and SO4 2 negative is irrelevant. Now what we're going to do is just work this out. So we've got 32 plus 64 So that's going to give us a total of 96. Now look at the question. The question is asking us for what is the mass. 1 mole of SO4 dinegative is 96 grams because it's asking us for mass. Next one. What is the mass of 1 mole of aluminium sulfate? So in aluminium sulfate, again, we need the details here. So we've got Al2, so let's go find each of these in the periodic table. So Al is 27, we found that one earlier on. We have actually found SO4 just in the previous question, but if you didn't have that, you'd have to go work it out individually. So we worked out SO4, when you add it up, is 96. So SO4 is 96. But this particular question says we have Al2, and then we have SO4 3. So we've got to do 2 aluminiums, which is 2 times 27, plus, and this 3 here refers to 3 times the SO4. So it's 3 times 96. So we've got 2 times 27, so that gives us a total of 54, plus 3 times 96 is 288. And then we add those two together. That's 342. Now again, this is 342 grams because it's asking what is the mass of 1 mole. So that there is 1 mole. And from that you can find 2 moles or 3 moles or 10 moles, or you can find 0.1 moles. Let's move on to the next question. What is the mass of 1 mole of hydrated copper to sulfate? So you can see the chemicals themselves are getting a little bit longer. So we've got CuSO4 dot 5H2O. So I'll just change that. So we've got to find copper, we've got to find sulfate, and we've got to find 5H2Os. Now we've already worked out the sulfate, we worked it out to be 96. Okay, so that is sulfate, SO4. So we've got to add copper to it. So again, if we go back to our periodic table and go find copper, copper is here. So copper is coming in at 63.54. So that's 63.5. So you round to either the lowest number, the highest number, the one in the middle. 63.5. So 63.5 plus 96. And then you have, so that's done. So now you have this bit, the 5H2O. Now we've already worked out H2O up above. It's water, which is 18. So the dot actually just means to add it on. It doesn't mean multiply like it does in maths. So this is going to be plus 5 times 18. And the 18 is the water. And again, you can add all that up. That works out at 249.5. And again, grams, because it's asking for the mass of 1 mole. And then finally, the last one is a little bit more complicated. Let's have a look at it. It says calculate the mass of 0.125 moles of calcium chloride. So we did 3 moles earlier on, which was easy. Now we've got to find 0.125 moles. So in order to start this, you start off with 1 mole. You always start with 1 mole. And we're doing 1 mole of calcium chloride, CaCl2. So we go to our periodic table and we go work out what 1 mole of CaCl2 is. You just add up all the numbers. Calcium on our periodic table is over here, which is 40. So calcium is 40 plus 2 times 35.5. Chlorine is 35.5. So we've got 40 plus 71. So that gives us a total of 111 grams. Now, that is for 1 mole. But the question is not asking for 1 mole. The question is asking for 0.125 moles. So how do we get 0.125 moles? So to get 0.125 moles, to go from 1 mole to 0.125, you're going to have to multiply by 0.125. You will also have to do the same to this one here to keep the equation balanced. So it's 111 multiplied by 0.125. And that gives us 13.875 grams. So that's your final answer for 0.125. So there is a little bit of a quicker way of doing this, rather than going and working out 1 mole first. We're going to do a thing called the mole diagram. And the mole diagram is a way of condensing all these calculations into an easy to remember diagram. Now, sometimes it's easier to use the diagram. In fact, most of the time it's easier to use the diagram. So why do we do it this way? We do it this way because in some calculations, you may have to work with these type of calculations. So it's handy to know both of them. Let's have a look at the mole diagram. I'll explain what it is and we'll do some examples. That's in part 3.